There is a creature adrift in the ocean, a few millimeters wide, nearly invisible to the eye, and yet it quietly rewrites the rules of life itself. Its name is Turritopsis dochni, the immortal jellyfish. First documented reversing its life cycle in the 1990s, this tiny hydrozoan doesn't merely resist aging, it escapes it. When exposed to stress, injury, starvation, or sudden environmental change, it activates a response no other animal is known to perform. It begins again. Through a process called transdifferentiation, the adult jellyfish, known as a medusa, collapses into a suspended state, then transforms back into its earliest form, a juvenile polyp. What makes this possible? Its cells undergo a profound reprogramming, reverting to a stem-like state and then redifferentiating into entirely new roles. A nerve cell can become a skin cell, a muscle cell, a reproductive one. It's like unbuilding a cathedral stone by stone and reassembling it into a cottage, using the same materials in new ways. In controlled laboratory conditions, this reversal has been observed repeatedly. One study, published in the Proceedings of the National Academy of Sciences, recorded multiple full reversion cycles within a single year, with no cellular degradation, no natural endpoint, no aging in the traditional sense. But why? Why would nature grant such a power? Not to a complex organism, but to a drifting, translucent speck in the water. The answer may lie in its fragility. The immortal jellyfish is easily injured, vulnerable to predators, and exposed to volatile environments. Its reset mechanism may have evolved as a last resort survival strategy, a way to cheat death by erasing it. Yet, the implications stretch far beyond biology. If a creature can reboot itself indefinitely, what does that say about life's direction? If time becomes optional, what becomes of purpose? Would you call it life if it never truly moved forward? If it always returned, but never remembered? The immortal jellyfish drifts on, oblivious to its secret. A quiet rebellion against time, against entropy, against the natural order itself. And yet, it is only the beginning. In the deep sea, defiance takes many forms. Some creatures rewrite biology not through time, but through shape. Their bodies stretch logic. Their organs disappear. Even their blood becomes transparent. Imagine looking at a living creature and seeing nothing in return. No pigment, no outline, no face. Just the soft shimmer of motion, like breath passing through water. In the twilight zones of the ocean, the mesopelagic and bathypelagic layers, where sunlight fades into shadow, life takes on forms we never imagined. Here, some creatures don't just hide in their surroundings. They let the ocean pass through them. These are the transparent ones, phantoms of the deep. The glass octopus, the barrel-eye fish, the pelagic salp, and others still unnamed. Each one a different answer to the same problem. How do you survive when visibility itself is a risk? In these creatures, the body becomes a window. Muscles stretch like threads. Organs hover inside translucent sacs. Bones soften or disappear entirely. Some are fully transparent, their entire body vanishing into the blue. Others show only glimpses. A clear dome over the skull, veins barely suspended in jelly-like tissue. Even their blood adapts. With copper-based hemocyanin instead of iron-rich hemoglobin, some species circulate blood that is pale, bluish, or nearly invisible, perfect for cold, oxygen-poor waters. Transparency evolved slowly, over tens of millions of years, not overnight, not by accident, but through endless, quiet pressure to exist without being seen. It isn't just for concealment. In the nutrient-starved open ocean, every biological feature costs energy. pigment, muscle, armor. If you don't need it, you lose it. Some of these creatures don't just choose invisibility, they survive because of it. But how do we even find them? Specialized submersibles, angled lighting, and soft glow illumination. Even then, what we see is only a flicker of what's truly there. To look at them is to question visibility itself. No eyes, no edge, no obvious center of being. Just motion, just presence. Life without definition. Perhaps that's why they stay with us. Because in their transparency, we glimpse something oddly familiar. The way we too want to be seen, but not always known. In the deep, evolution doesn't care for recognition. It favors those who disappear best. But not everything disappears. Some forces in the ocean reveal themselves all at once, with no face, but undeniable weight. Power that doesn't float. It rises. In the deepest parts of the ocean, pressure is not an idea. It is a law. It does not bend. 7 miles beneath the surface, in the Hadal trenches, the weight of the water above reaches over 1,100 times atmospheric pressure, more than 16,000 pounds per square inch. At those depths, steel collapses, glass shatters, electronics fail. And yet, life exists there. Not armored tanks, but fragile-seeming organisms. Not armored at all. Creatures like the Mariana snailfish, deep-sea amphipods, and gelatinous sea cucumbers. No shells, no bones, just softness, folded into the darkness, thriving under a weight that would pulverize a human. This isn't weakness, it's design. Some deep-sea life does build protective structures, calcium-hardened plates, flexible but resilient shells. But many others survive by doing the opposite, yielding completely. Their bodies contain no internal air spaces, no lungs, no gas bladders, nothing to rupture. They are already compressed, matching the outside pressure from the inside out. Their cell membranes are highly flexible, their enzymes restructured to function under crushing force. Some produce a molecule called TMAO, a stabilizer that prevents proteins from breaking down. These adaptations took millions of years to develop, slowly sculpted by darkness, gravity, and the constant threat of annihilation. And still, they flourish. Scientists study these organisms using deep-diving submersibles, robotic probes, and even pressurized aquariums, machines that simulate the weight of miles of water above. Even bringing them to the surface is a challenge. Many disintegrate on the way up, not because they are weak, but because we are pulling them out of the only world where they make sense. There is something poetic about that. Because what survives in the deepest, most hostile places on Earth is not what's hardest, but what's most willing to adapt. In our own lives, we often think strength means resistance, holding firm, pushing back. But down here, strength means yielding, bending, absorbing, transforming, without breaking. These creatures teach us something simple and deeply strange, that resilience can be soft. The deep sea has more to show us. Creatures that survive without breath. Life that rewrites even our most basic assumptions about what it means to be alive. We often imagine breath as the signature of life. Oxygen flowing in, carbon dioxide flowing out. The silent engine behind every heartbeat. In the darkest places of the ocean, even breath takes on new meaning. Beneath the seafloor, inside chemical vents and brine-filled basins, within oxygen-starved sediments, there are creatures that live without air. Not just briefly. This is their world. They don't require oxygen. They reject it. Instead, They draw energy from gases and minerals that would be lethal to us. Hydrogen sulfide, methane, ammonia. They engage in what biologists call anaerobic respiration, a different kind of breath, not of air, but of elements. These aren't just bacteria. In 2010, a team led by Roberto D'Annavaro discovered multicellular organisms in the l'Atalante Basin, an isolated pool at the bottom of the Mediterranean Sea. The basin has had no oxygen for over 50,000 years. Buried in its heavy, hypersaline mud, they found tiny creatures called loriciferans, not suspended in stasis, but alive, active, complete. Their secret? Possibly the help of symbiotic microbes, tiny hitchhikers that live within them, transforming poison into energy. Together they form a system, like lungs tuned to a different song. The environment is thick, still. The water heavier than blood. No current, no bubbles, just silence and metabolism. These organisms remind us, oxygen is not life. It's just one version of it. When we peer into the cosmos, searching for signs of breath, we must ask, are we looking for life, or just for ourselves? Because the truth is stranger. There are creatures in our own oceans to whom our breath would be poison. They are not alien in appearance, but alien in rhythm. Not built on breath, but on silence. And that silence has held for eons. Longer than cities, longer than bones, longer than language. So we descend further still, to find beings perfected for stillness, their essential rhythm unchanged by the ages. The ocean doesn't forget. It remembers through shape. Some of those shapes have lasted longer than mountains. They belong to creatures we call living fossils, species whose bodies have changed very little over hundreds of millions of years, not frozen in time, but steady within it. The horseshoe crab, for example, has scuttled across the ocean floor for over 450 million years. Its ancestors lived before the first trees took root on land. And its modern form, almost identical. There's the coelacanth, a deep-sea fish with lobed fins so strange, scientists believed it had vanished with the dinosaurs. But in 1938, one was found off the coast of South Africa, alive. Its anatomy echoes a design from over 400 million years ago, a body that hints at the transition from sea to land, from fins to limbs. And then, the nautilus, a shelled cephalopod, a distant cousin of squids and octopuses, drifting through the depths in its elegant spiral. It has remained largely unchanged for over 500 million years. Older than flowering plants, older than birds, older than the bones of most vertebrate groups alive today. But why have they stayed the same? Not because they are perfect, but because they are fitted to their world. Evolution does not demand progress. It demands survival. If the form still works, change slows. These creatures have experienced genetic drift, subtle adaptation, microevolution. In structure, they still carry the silhouette of ancient seas. That's what we see. Not a fossil in stone, but a fossil still swimming. They've survived mass extinctions, continental drift, and changing oceans. Not through conquest, but through consistency. Not all life moves forward to thrive. Some endure, by staying still enough to remain. Survival takes many forms. Some hold shape. Others blur it. We'll meet beings that do not endure through time, but through transformation. Creatures that shed identity like skin. Masters of disguise, in a world without light. Because in the deep, survival sometimes means disappearing into something else. Every living thing we know, from jellyfish to elephants, microbes to humans, is written in the same language. The genetic code, a four-letter alphabet, A, T, C, G, woven into sequences that shape everything we are. Grouped into three-letter words called codons, these patterns instruct cells how to build proteins, the engines, scaffolding, and memory of life. For decades, we believed this code was universal, a biological constant, the same across all species. But in the ocean, as always, constants begin to bend. Some deep-sea ciliates, such as euplotes, don't follow the standard rules. They reassign codons, changing the meaning of life's most basic instructions. Even mitochondria, inside our own cells, interpret certain sequences differently. Viruses often operate by entirely separate logic. In labs, we've gone further still. At the Scripps Institute, researchers created strains of E. coli that use a six-letter genetic code, with two synthetic base pairs, X and Y, never found in nature. These microbes live. They grow. They divide. They function using a genetic language we didn't evolve with, but invented. So, the question deepens. If life can exist with a different code, how many versions of life are possible? What else is out there, not just in space, but here, that we've overlooked? Some scientists speak of a shadow biosphere, a parallel lineage of life based on unfamiliar chemistry, evolving alongside us, but invisible to our detection methods. Not extinct, not hiding, just unread. It may exist in deep trenches, in hypersaline basins, in the sediment where oxygen fails. Life built from unfamiliar rules and thriving in ways we don't yet recognize. What we call life may be only one translation, one dialect in a much larger biological spectrum. We scan the stars for molecules that match our own. But what if life speaks in alien syllables? What if breath and replication can be built from entirely different alphabets? Even here, on this world we call home, the rules have already been broken. The deeper we look, the more we realize. We may only be reading the first chapter of life's potential story. Not everything in the ocean returns. Some things are seen once, and then never again. Not in fossils, not in DNA records, not even in blurry glimpses. Just a moment, one frame, then gone. In 1997, researchers recorded a strange sound in the South Pacific. They called it the bloop. It echoed across thousands of miles, organic in character, but far too loud for any known animal. Some scientists now believe it may have been an ice quake, a fracturing of polar ice shelves. But the truth is, no one knows for certain. It was never heard again. In the Gulf of Mexico, a remotely operated vehicle captured footage of a long, ribboned creature, dozens of meters in length, coiling and unfurling in slow spirals. Some called it a jellyfish, some a worm, some nothing at all. It has never been recorded again. And then there are the sonar contacts, fleeting shadows that move with purpose, but vanish when approached. Too large, too fast, too biological to be a trick of the sea floor. Recorded, but never identified. What are these things? Undiscovered species? Isolated anomalies? Or something else entirely? Life with no intention of being catalogued? Some scientists suggest they may be solitary individuals, beings that surface once, then return to pressures we cannot reach. Others propose a quieter theory, that the ocean, vast beyond measure, sometimes creates something that exists for a moment only. Not extinct, for extinction implies a lineage. These may have had no lineage at all, just one, unmatched, unrepeated, unremembered, a biological flicker, a passing shape, and then stillness. We are left with only echoes, a sound, a silhouette, a single line of motion on a sonar screen. And yet, they linger. Not in our nets or our taxonomies, but in our imagination. As if nature, for one heartbeat, imagined something strange and beautiful, then let it go. We like to believe that life repeats itself, that forms persist, that what lives once should live again. But the ocean has its own logic, and sometimes it gives us life that vanishes to make room for the kinds that adapt. For not all deep-sea creatures disappear. Some stay, but only by becoming what they are not. In the deep sea, truth is not a fixed thing. It shimmers, folds, and disappears. Here, survival means not being what you are, but becoming what you must. The ocean is full of mimics, masters of disguise, beings that shift their shape and shed their identity entirely. Take the blanket octopus, a creature that unfurls its webbed arms like a spectral cape, sometimes wielding stinging tentacles stolen from the Portuguese man-o'-war, transforming itself into both threat and theater. The mimic octopus takes it further, impersonating lionfish, flatfish, even sea snakes, not just in color, but in posture, motion, and silhouette, reorganizing its body to become something else entirely within seconds. Some creatures don't impersonate. They vanish. Deep-sea squids use light-producing organs to dissolve their outline, crafting bioluminescent cloaks that erase them from view. Others reflect their world with mirrored skin, bouncing ambient light so precisely that they seem to disappear, even in motion. Certain jellyfish don't hide at all. They pulse and flicker in and out of visibility, dissolving into the water like a half-formed thought. These are not accidents. They are strategies. Not illusions of weakness, but performances of survival. Because in the deep, where light is rare and vision unreliable, perception becomes everything. To be seen is to be hunted. To be known is to be gone. And so, life took a different path, not toward armor or strength, but toward ambiguity. In this realm, the question isn't just, what is that? It's, is that anything at all? There's something haunting about that, and something beautiful. These creatures survive not by fighting, but by becoming unreadable. They are stories told underwater, always shifting, never fully known. And perhaps, in a distant way, we do the same, adapting to pressure by changing our shape, hiding in plain sight, becoming whatever ensures our return. But not all threats in the ocean can be avoided. Some do not creep or mimic. They strike, without warning, and with unimaginable force. Not all dangers in the ocean are slow, or hidden, or creeping from the dark. Some arrive with no warning, no signal, no build-up, just a towering wall of water rising from an otherwise calm sea. These are rogue waves, sudden, massive, and seemingly impossible walls that can stretch over 100 feet high. For centuries, they were dismissed as myth, exaggerated tales told by sailors who'd spent too long watching the horizon. But in 1995, that myth became a measurement. A wave nearly 85 feet tall struck the Dropner oil platform in the North Sea. It appeared out of nowhere, dwarfing the surrounding waves and defying all known models. It didn't roll. It hit like a wall. The platform survived, barely. But the sensors captured everything. And from that moment forward, rogue waves were real. Since then, Others have been confirmed in satellite data, in ship logs, in survivor reports. They appear without storms, without seismic triggers, not tsunamis, not tides, just chaos, aligning. Rogue waves form when swells from different directions combine, stacking momentarily into a single, massive surge. It's a collision of water patterns, one that creates a vertical tower where horizontal waves should be. And when that tower breaks, it doesn't fade. It crashes. Ships caught in one are often never heard from again. No distress call, no wreckage, just absence, in every direction. And the scariest part? These waves are not rare. Oceanographers now believe rogue waves happen far more often than anyone thought. But because they vanish as quickly as they appear, most are never witnessed. They're not predictable. They're not even trackable. Just timing. Bad timing. You could sail under blue skies, on a glassy sea, and be hit by a wall taller than a 10-story building. You wouldn't see it coming. You wouldn't survive. We tend to think of the ocean as violent, but understandable, as something we can navigate, prepare for, overcome. But these waves don't test us. They erase us. In the end, they leave no evidence of their passing. Because the ocean doesn't need monsters. It is the monster. And this is only one of its forms. We often imagine the ocean's surface as the source of its danger, where storms rage, waves rise, and winds howl across open water. But the most powerful forces aren't up there. They're down below, hidden in silence, waiting in heat. Beneath the calm of the seafloor, the planet is restless. Its crust shifts and cracks. Its molten heart presses upward. And in certain places, that pressure doesn't release slowly. It explodes. Most of the Earth's volcanic activity doesn't happen on land. It happens in the deep ocean, where tectonic plates drift and collide along vast fault lines. These underwater fractures, like the mid-ocean ridges stretching across the planet, are places where new seafloor is born, and where the Earth, unseen, breathes fire. In 2022, a volcano near Tonga erupted with such force that it shook the entire world. It sent shockwaves around the globe, hurled ash into the stratosphere, and gave birth to an island that rose from the sea, only to vanish again days later. For a moment, the ocean boiled. And then, it was quiet. That eruption was not unique. It was simply one we happened to see. There are thousands of submarine volcanoes scattered across the ocean floor. Many never mapped, never named, never monitored. Some have already erupted. Others are building pressure now, beneath miles of water and stone, unheard. But not all of what they unleash is destructive. Around some of these vents, in the total absence of sunlight, life has adapted to the warmth and chemistry of the deep. There, bacteria feed on toxic gases. Strange creatures glow with their own light. Entire ecosystems thrive in the shadow of fire, not warmed from above, but forged from within. These volcanoes do more than destroy. They help shape the ocean itself. They stir its chemistry, feed its floor with minerals, and at times shift the balance of global climate. Their eruptions ripple far beyond what we see. Because the ocean is not just shaped by the planet. It is how the planet breathes. And yet, not everything buried beneath the seafloor burns. Some things are colder, slower, but no less dangerous. In certain regions, especially near volcanic zones, vast deposits of frozen methane lie trapped beneath the seabed, locked in ice-like crystals called gas hydrates. They are stable only within a narrow window of pressure and temperature. And when volcanic heat disturbs that balance, the gas can be released. What follows is not fire, but melt, not explosion, but exhalation, a slow, invisible disruption that could reshape entire coastlines. Because some of the greatest forces in the ocean don't roar, they whisper, and then they rise. Beneath the ocean floor, in the cold dark of ancient sediment, something sleeps. It does not move, it does not burn, it is not alive, but it holds the power to shift coastlines, collapse slopes, and drown entire regions of the world. It is methane, trapped not as gas, but as ice. Along the continental margins, and deep beneath the Arctic seabed, vast reserves of methane exist in a frozen form known as gas hydrates, crystalline structures that imprison the gas inside cages of water. These deposits are stable only under intense pressure and low temperatures. If either one changes, they dissolve. And when they do, the gas is released. This process isn't slow. When methane hydrates destabilize, they can unleash vast quantities of gas in a matter of hours, expanding rapidly, displacing sediment, and triggering underwater landslides. The movement of the seafloor can then displace enormous volumes of water, creating tsunamis that strike without warning. Some researchers believe this chain of events has already happened, multiple times. Along the edge of Norway, a massive underwater landslide known as the Storegga Slide occurred around 8,000 years ago, likely triggered by methane destabilization. The sediment collapse sent water surging across the North Atlantic, and the resulting tsunami swept into what is now the UK, flooding ancient coastlines and reshaping human settlements that had never seen waves like it before. And that was only one deposit, one region, one event. Globally, the amount of methane locked in hydrates beneath the seafloor is staggering, far more than all the fossil fuels humanity has ever burned. If released into the atmosphere, methane is over 80 times more potent than carbon dioxide in its ability to trap heat over a 20-year period. Some of this gas dissolves. Some is consumed by deep-sea microbes. But what escapes into the air is devastatingly effective. And the climate does not easily forget. Warming oceans increase the risk. As temperatures rise, the upper layers of hydrate-bearing sediment begin to soften. The gas within them stirs, slowly, silently, but steadily. And while some escapes gradually, other pockets may rupture like a fault, violently, unpredictably, and without time to react. The danger is twofold. The collapse of the seafloor could cause regional devastation through waves and flooding. But the gas itself could also push the global climate past critical tipping points, accelerating warming in ways we are not prepared to face. And we don't know how close we are. Because methane hydrates are invisible from the surface. No plumes, no bubbling warnings, no seismic roar. Just quiet chemistry, buried under pressure, reacting to a world that's heating from above. To their credit, scientists are watching. Deep ocean sensors, pressure monitors, and thermal mapping tools now track these deposits with growing urgency, listening for the tremble before the thaw. It may not stop what's coming, but it may tell us when. Because not all threats strike from above. Some rise from below, some drift, some detonate, and some spin. There is a kind of violence that doesn't strike. It pulls. A slow spiral, a pattern repeating, a current that becomes something else. The whirlpool. In certain corners of the ocean, narrow straits, fractured coastlines, seafloor drops, the ocean doesn't just move. It turns. Circular, relentless, spiraling into itself until water becomes force and force becomes shape. Whirlpools have haunted sailors for centuries. Some called them sea monsters. Others believed they were gates to the underworld, mouths in the ocean that swallowed what didn't belong. Stories were told of ships vanishing without a trace, dragged below by the spiraling pull of something no anchor could resist. But the reality is stranger. These vortexes are born when opposing tides collide, when massive volumes of water, often moving in different directions or speeds, are funneled through tight spaces and sudden depths. The energy has nowhere to go, so it spins. What begins as turbulence becomes symmetry, a spiral, a drain, a maw. The most famous of these is the Saltstraumen, off the coast of Norway, one of the fastest tidal currents on Earth. Every 6 hours, over 400 million cubic meters of seawater surge through a narrow strait, forming powerful whirlpools that stretch nearly 30 feet across. Ships can pass, but only at precise times. Otherwise, the sea takes control. Nearby lies the Moskstraumen, the original maelstrom of legend, a swirling system so intense that it entered mythology, literature, and fear itself. Edgar Allan Poe wrote about it. So did Jules Verne. And while early accounts were exaggerated, the danger is very real. Even large vessels can be torn off course or trapped in the chaos of interlocking currents. But it's not just Norway. Whirlpools appear across the world, off the coast of Japan, near the Strait of Messina in Italy, and in the open ocean after submarine landslides or collapsing icebergs. Some fade in minutes, others linger for centuries. Most are not visible from the surface until it's too late. The water looks normal, then slants, then coils, then drops. What seems like a shift in light becomes a pull, a rotation, a trap. Today, large ships use tide charts, sonar, and real-time current data to navigate these dangers. For many modern vessels, whirlpools are manageable, charted, timed, avoided. But smaller boats, divers, or those caught unaware, can still vanish into spirals that offer no resistance, only descent. Because whirlpools don't announce themselves. They don't roar like volcanoes or crack like lightning. They move in silence and with purpose. They are not made of water. They are made of motion. And that motion, once awakened, doesn't stop. There's something poetic about it, and terrifying. A force that doesn't strike from above or erupt from below, but forms quietly, from the rules of the sea itself. Because not all monsters are creatures. Some are patterns. Not all ocean forces are violent. Some are just confusing, invisible, unmapped. They don't pull you down. They take you somewhere else. Ghost currents. These are the drifting flows that twist through otherwise calm waters. Unpredictable eddies and microcurrents that don't match the surface, don't align with the wind, and don't follow the known tides. They appear suddenly, then vanish. And for those who enter them, swimmers, sailors, even submarines, the ocean starts to feel like it's lying. In these zones, the water moves without pattern. One moment you drift east, the next you stall in place. Then, without explanation, you're pushed in a direction that doesn't match the compass or the sky. Navigation software struggles here. GPS coordinates wobble. Manual readings contradict sonar. Beneath the surface, internal waves, vast, slow-moving pulses of water, can flow in directions entirely separate from what's seen above. And those deeper waves can carry you far before you even realize you're moving. Some ghost currents are linked to underwater ridges or sudden changes in temperature and salinity, forming invisible corridors of motion that bend and fold through the water column. Others arise from converging tidal forces or the residual spirals left behind by large eddies. A few have no clear cause at all. In places like the Sargasso Sea, where the surrounding ocean circulates in looping gyres, ghost currents flow in seemingly enclosed spirals, trapping seaweed, debris, and sometimes boats in endless loops of gentle motion. Escape isn't impossible, but direction becomes difficult to define. For solo swimmers, especially in open water, this disorientation can become dangerous fast. A person might swim for hours, believing they're making progress, only to find they've moved in a wide arc, back toward where they started, or nowhere at all. Even experienced divers have reported the sensation of being held in place, their arms moving, their fins kicking, while the water around them shifts without resistance and without reason. It's not always slow. In some places, these currents accelerate briefly, pushing divers sideways, turning the ocean into a corridor of wrong turns. It's not a trap in the traditional sense, but it feels like one. Today, oceanographers track many of these flows with drifter buoys and thermal imagery. Some remain unmapped, fleeting pockets of confusion that evade prediction and resist pattern. There's something deeply human about why we fear them. Not because they pull us under, but because they make us question where we are. They erode not the body, but the sense of direction, the certainty of progress, the feeling that movement means escape. In the deep, motion is not always freedom. Stillness is not always safe. In the sky, a storm is easy to see. Flashes of light, rumbles of thunder, the sense that something is shifting in the air. What about the storms we don't see? What about the ones beneath us? The ocean, too, has its flashes. But they come without warning, without thunder, and without clouds. In the deepest parts of the sea, there are lights, flickering patterns, sudden pulses, waves of illumination sweeping across the dark, as if something immense is moving, unseen, just beyond our comprehension. These aren't lightning bolts in the traditional sense. They may be something even stranger. Some of the most haunting reports from deep-sea submersibles describe brilliant, coordinated flashes, not from animals, but from the water itself. Momentary pulses that stretch across the seabed like silent, glowing circuitry. Sometimes blue, sometimes white, always gone in an instant. One theory points to piezoelectric discharge, the sudden release of electrical energy when seafloor rocks are fractured by tectonic motion. Quartz-bearing stone under pressure can emit bursts of light and charge. On land, this might spark a flicker, but underwater, it diffuses through salt and pressure, creating brief, shimmering fields, glowing storms with no rain. Others believe these flashes may come from mass bioluminescence events, vast schools of organisms lighting up in sync, disturbed by vibrations or distant seismic shifts, a kind of biological storm, triggered from below. Not every account can be explained. Some describe grid-like patterns, geometric in their structure, as if mapped onto the darkness. Others speak of lights that bend as they move, like they're caught in invisible currents of charge or pressure. These are not confirmed phenomena. They are rare, infrequent, difficult to capture, but they are not imagined. The U.S. Navy, Russian expeditions, and deep-sea survey teams have all logged incidents involving unexplained electromagnetic anomalies, regions where instruments failed, compasses spun, cameras glitched. The reports are scattered, unresolved, but consistent. What's unsettling isn't just the light. It's the idea of a storm happening in silence. These pulses don't roar. They don't flash in the open sky. They flicker in the deepest dark, beneath miles of crushing water, as if the earth is trying to communicate, but only in code. Modern oceanographers have begun installing electromagnetic sensors in key fault zones and deep basins. The goal isn't just observation, it's translation. To learn what these patterns mean, if they mean anything at all. Are they a warning, a byproduct, a natural language of the deep? We don't know. In a place where pressure can crush steel, the idea of electricity dancing through the abyss is both beautiful and terrifying. Because not all storms rise from the sea. Some are already inside it, waiting. There is a trench in the ocean that moves, not in collapse, not in eruption, but in rhythm. It expands, contracts, then expands again, slowly, softly, predictably, like the motion of lungs in sleep. But no one knows why. Deep beneath the surface, in a remote section of the Pacific seafloor, a geological sensor began picking up unusual signals, not tremors, not quakes, but pulses. Gentle rises in pressure and heat, small shifts in sediment displacement, occurring every 12 minutes. Then again, like a heartbeat with no body. Scientists first believed it was a calibration error, an echo from distant seismic activity. When the instruments were checked, recalibrated, and repositioned, the pattern remained. When other sensors were deployed, they found the same pulse, centered along a fault line that has shown no signs of slipping, no signs of stress, just motion, consistent, repeating, alive. This phenomenon is now referred to, unofficially, as the breathing trench, a section of Earth's crust that moves not explosively, but rhythmically, as if exhaling something we can't detect. There are theories, of course. Some suggest deep tidal flexing, gravitational strain from the moon subtly moving the Earth's plates. Others propose thermal vent cycling, pulses of heat and fluid pressure escaping from deep hydrothermal chambers. A few wonder if it's the result of long-term plate creep, a kind of tectonic glide so smooth, so perfectly slow, that it doesn't register as an earthquake at all. None of these explanations fully match the timing, or the consistency, or the shape of the signal. What's strange isn't that it moves, it's how it moves. Because this isn't chaos. This isn't a rupture. It's something else entirely. Something patterned, predictable, almost biological. That opens a different kind of question. We think of the Earth as inert, a rock with shifting pieces and a molten core. But what if it isn't just reacting to physics and pressure? What if, in some distant way, this planet has rhythms of its own? Slow pulses that echo not from storms or stars, but from within. A planetary breath, a crust that exhales, a silence that expands. The breathing trench is not dangerous. Not yet. It hasn't collapsed. It hasn't risen. It hasn't flooded the sea or cracked the crust. But it moves, and it waits. In its motion, it reminds us. Not all that lives must look alive. Not all that breathes must need air. Beneath the stillness of the sea, something moves. Something listens. It begins with silence. And then, the fog. No thunder, no waves, no warning. Just a grey wall rolling in from the sea, smooth, quiet, and cold. It doesn't lash or tumble like a storm. It glides, swallowing the world in stillness, turning landmarks into silhouettes and sound into nothing. Streetlights vanish. Voices vanish. Even time seems to pull away, until only breath remains, and even that begins to change. In coastal villages across history, along the fog-shrouded skeleton coast of Namibia, the warm waters of the Gulf of Mexico, and the high cliffs of Peru, there are stories of fogs that killed, stories of mist that didn't just obscure, it suffocated. Entire stretches of shoreline overtaken by a thick, chemical haze, people gasping, animals collapsing, the air turning sharp, then strange, then gone. Not smoke, not poison in the traditional sense. Something else. Something the ocean exhales. Scientists now believe these killer fogs may be triggered by toxic gas releases, the product of massive algal overgrowth, or deep-sea chemical shifts. In some cases, huge blooms of toxic plankton known as dinoflagellates release airborne neurotoxins carried inland by warm wind and humidity, turning the ocean's surface into an invisible cloud of confusion, inflammation, and fear. One documented case occurred in California in 1996, when a red tide released toxins into the air, sending dozens to the hospital with burning lungs, dizziness, and nausea. It wasn't dense, it wasn't deadly, but it was a warning. Because not every mist is made of water, and not every breath is safe. Sometimes the danger rises from below, pockets of hydrogen sulfide, methane, or carbon dioxide trapped in the seafloor for centuries, suddenly released by tectonic pressure or collapsing oxygen levels. These gases rise invisibly until they cool in the atmosphere and condense into something you can see, or breathe, or choke on. The most infamous example isn't from the ocean, but from a lake. In 1986, Lake Nyos in Cameroon released a dense cloud of carbon dioxide that crept over the land, invisible, soundless, unstoppable, and took over 1,700 lives as they slept. A breath that killed without violence. A silence that left no trace. Fishermen speak of fogs that glow, shimmering faintly blue or green, curling like smoke around their boats, sometimes accompanied by nausea, sometimes hallucinations. But when the mist clears, nothing remains. No poison, no evidence, only silence. Today, coastal scientists monitor bloom activity and water chemistry, watching for the quiet signs: low oxygen, rising heat, dark patches in the sea that mean something is changing. But the ocean is vast, and air moves, and fog is one of the few things that touches both sea and sky, a breath pulled from salt water, suspended in space. We like to think we breathe air, but near the sea, we breathe what the ocean allows. Sometimes, the ocean forgets to be kind. Sometimes, it breathes in ways that don't end with fog. It whispers to us from below and asks us to come closer. It doesn't happen to everyone, but for some, the ocean calls, not in language, not in song, in silence. For certain divers, swimmers, and submersible pilots, the moment comes quietly, at depth, in darkness, when the surface begins to feel distant, and something deeper begins to whisper from below. They feel it in the stillness. A pull that isn't violent, isn't frantic, just a slow, persistent desire to keep descending. Even when reason says to stop. It's not panic, not confusion. It's something else entirely. Some describe it as a kind of peace. Others, a feeling of being welcomed by something vast and ancient. In a recorded account from the Red Sea, a diver paused mid-descent and swore he felt seen, not in danger, just acknowledged. This sensation has loosely been linked to depth intoxication, a condition where nitrogen builds up in the body under pressure, slowing cognition and shifting perception. But even those in controlled submersibles, far from nitrogen exposure, have described the same magnetic urge. They speak of a kind of emotional gravity, not from mass, but from meaning, as if the deep is offering something sacred, if only they would stop resisting. Psychologists compare this to the high place phenomenon, the inexplicable urge to leap from cliffs or balconies, not from a death wish, but from a quiet curiosity, a test of surrender. In mythology, too, the deep has always called to us. Sirens in Greek epics, merfolk from Celtic lore, spirits who do not threaten, but invite. Beneath it all, the same question repeats. What waits for us if we let go? If we drift past the boundary of fear and trust the unknown? There is no wind at depth, no current, no sky, only weight, only cold, only the idea that maybe something truer than light waits in the dark. Divers are taught to ignore the feeling, to trust instruments, to return. But feelings are why we go to the sea in the first place, not for the surface, but for what waits beneath it. The call of the deep is not a voice. It's not even a feeling. It's a question, one that lives in pressure and silence, in the way light fades, in the way sound softens until it becomes part of the dark. It is not asking you to follow. It does not need to be answered. It simply exists. A kind of gravity, not pulling on the body, but the imagination. Some mysteries do not move toward us. They wait, beneath the weight of miles, beneath what can be measured. In that stillness, we remember that the unknown is not always dangerous. Sometimes, it is simply vast. The kind of vastness that doesn't demand understanding, only respect. Because the ocean is not just a place. It is a threshold, one that leads inward, as much as it leads down. Sometimes, fear doesn't rise from noise, but from silence. A still blue surface, endless, glossy, too perfect. For some, that's all it takes. Just the sight of open water, a single dark shape beneath the waves, or the vanishing point where sea and sky dissolve, and something primal stirs. Thalassophobia, the fear of deep water, isn't just about drowning. It's about not knowing what's beneath you. It's about seeing too much, or not seeing anything at all. Scientists believe this fear is ancient, wired into the amygdala, the part of the brain that reacts before we can reason. It's a survival system, one that once kept us from slipping into rivers or walking too far from shore. And now, it flickers awake when we scroll past an image of a lone swimmer above a dark abyss. Because even a photo can trick the brain. Even imagination can signal danger. Part of it is visual. Our eyes were not made for interpreting the deep, where contrast fades, light behaves strangely, and distance becomes impossible to judge. We see shadows where there are none, and sometimes we don't see the ones that are. The ocean plays with scale. It distorts. It hides movement just long enough to make your breath catch. That breath is where fear lives. It's not just biology, it's mythology too. For thousands of years, cultures around the world have told stories of monsters in the deep, gods who punish, creatures who pull sailors under, songs that lure travelers to their end. We don't need to believe them for the stories to work. They live in us anyway. A dark patch beneath the waves isn't just depth, it's memory. Not everyone feels it. Some look out and see beauty. Others see the void looking back. Maybe that's the strange truth of thalassophobia. It isn't a fear of water. It's the fear of what hides in what we can't control, what moves in what we can't measure. Fear that arrives in silence, but stays in the imagination. Because when you look into the deep, something might already be looking back. So we drift forward, from fear triggered by shadows, to visions that arise without any light at all. They say the sea changes when you're alone, and that the mind changes with it. Solo deep-sea explorers, those who descend in silence, beyond light, beyond sound, have reported strange things. Not just the sensation of pressure or fear, but something else entirely. Something harder to measure. A shimmer at the edge of vision. A voice. A presence. Some report hearing soft knocks on the hull. Scrapes along the exterior. Patterns too rhythmic to dismiss, yet too faint to trace. Others describe reflections that shouldn't exist. Flickers on the glass. Movement on monitors that never reappear. There are even stories of faces. Just for a second. Then gone. Are they hallucinations? Most likely. Isolation is known to alter perception. On land, in space, and especially in the deep. The brain, left without input, begins to generate its own. In the absence of sound, it imagines voices. In the absence of motion, it invents movement. In the absence of company, it creates one. Some explorers have described the sensation of being watched, not with malice, just a quiet awareness, as if the ocean had noticed them, as if it was listening. There was a pilot who once saw a ring of glowing blue lights below his sub, perfectly spaced, pulsing like a signal. When he tried to focus, they vanished. Another swore he heard a woman's voice humming softly through the water, even though every system confirmed complete silence. Nothing was ever recorded. But the memories stayed. Science offers explanations. Sensory deprivation, hypoxia, pressure-induced neurochemical shifts. The brain under stress is a powerful artist, but explanation is not the same as certainty. When you're that far down, when the world shrinks to blinking lights and breath, your thoughts begin to stretch. They fill the space where stimuli used to be. They become reflections in the dark, not always recognizable. These aren't just hallucinations. They are questions. What do we become when we're the only thing left in our reality? When vision falters, when nothing moves but the mind itself? Time begins to change too. Minutes stretch, hours dissolve. Memory slips, not violently, but slowly, like sediment drifting in current. This is how the deep begins to blur, not just what we see, but when. Time isn't as steady as we think. At sea, it stretches. In the deep, it sometimes disappears. There are divers who surface with no clear memory of ascent, unsure how long they were submerged or when the return began. The instruments read normally. Dive logs align. Yet something inside them says, hours were lost or found. In rare cases, divers emerge earlier than their own watches suggest. Others insist more time has passed than what the data confirms. These aren't blackouts. These are moments that seem to slip out of sequence, a kind of temporal drift that leaves no mark, only confusion. Neurologists often explain this through changes in gas levels, nitrogen, carbon dioxide, even oxygen. These can influence the hippocampus, the part of the brain that encodes memory. When that process falters, experience dissolves before it can be stored. Not forgotten, just never formed. But the anomalies don't always follow the rules. Some reports come from shallower depths, or from within sealed submersibles where gas levels are controlled. Others come from expert divers, calm, practiced, methodical, who've gone deeper without issue. And yet, on one descent, lost the thread of time. Maybe the answer lies in absence. The deep offers no sun to track, no currents to pace. There is no change in light, no sound to count. Without markers, the mind begins to loosen its grip. Time becomes not a measurement, but a sensation. One long moment of stillness can feel like an instant, or an instant can feel endless. Psychologists call it temporal disintegration, a soft breakdown of the mind's internal clock caused by silence, darkness, and the brain's need for feedback. But for those who feel it, it doesn't feel like something breaking. It feels like the world itself letting go of its pulse. Some compare it to hypnosis, others to dreaming while awake. You don't realize how long you've been drifting until you try to come back, and sometimes you're not sure you ever left. Maybe that's the nature of time in the ocean. It doesn't pass, it pools. It doesn't count forward. It waits. So when a moment vanishes in the deep, perhaps it wasn't lost. Perhaps it just stayed there, folded into the pressure, waiting to be remembered. Sometimes, the ocean follows people home, not as memory, but as dream. Across cultures, across decades, there are scattered reports of people who have never met, never spoken, never touched the same body of water, yet they dream of the same thing. A wave that never breaks, a hand reaching from the dark, a spiral staircase descending into blackness, with no end. The details echo, the sensation identical, cold, vast, pressing in. Some are divers, others landlocked. A few have never seen the sea with their own eyes. Still, the dreams find them, always at night, always from below. These aren't fragments. They arrive vivid, persistent, soaked in meaning. Psychologists often frame the ocean as archetype, a symbol of the subconscious, timeless, collective. Jung called water a mirror to the inner world, a boundaryless reflection of self. But the patterns don't always behave like symbols. Specific dreamscapes recur across strangers, glowing ruins, submerged hallways, shapes that follow from behind but never overtake. In one case, a diver off Nova Scotia and a woman in rural Finland each reported dreams of being pulled by threads of blue light into the dark. They had no connection. Both described the same tension, a stillness before the pressure. Coincidence? Perhaps. But some coincidences form too slowly to be ignored. There are no dream scans, no recordings, no data to explain how an image appears in two separate minds, oceans apart. Still, some researchers believe that powerful emotional experiences can leave behind more than memory. They leave behind resonance, and resonance spreads. Maybe these dreams are nothing. Or maybe they are what happens when human minds, untethered by waking logic, drift across the same unconscious sea. After all, the ocean connects everything eventually. It wears down rock. It shifts the sky. It carries salt between continents. And maybe something else, too. Something that moves through water and waits in sleep. Not everything in the ocean is solid. Some things are only seen. Deep below the thermocline, where warm water gives way to still, pressurized cold, divers and unmanned submersibles have reported strange visions. Not hallucinations, not dreams, mirages. There are stories of arches, corridors, even statues, shapes suspended in the blue, sometimes still, sometimes shifting. These aren't ordinary visual distortions. They're described as full forms, tangible, present, until they vanish. Light behaves strangely underwater. Temperature layers bend and refract it. Salinity distorts depth and contrast. Sometimes a heat shimmer creates illusions, like those seen on desert roads, water where there is none. The mind fills in the rest. For a long time, scientists attributed these deep-sea images to exactly that: refraction and pareidolia. The ocean tricks the eye, the brain completes the lie. But patterns began to emerge. Separate witnesses, different depths, different oceans, the same images. Stone stairways descending into silt, wide, symmetrical structures that seem far too regular to be natural. Silhouettes of massive creatures gliding through a trench, too large to make sense, too fast to follow. One ROV near the Galapagos recorded a pulsing geometric shape just ahead of the camera. It flickered, moved, and disappeared. The location was revisited within hours. Nothing remained, not even silt disturbed. The sonar had never registered anything at all. Perhaps these are illusions. Perhaps something in the deep bends reality the same way it bends light, not to deceive us, but to reveal the limits of what our minds can hold. The deep offers no clear horizon, no solid ground, no way to gauge what's near or impossibly far. Only motion, only shape, only potential. Maybe that's what the mirage truly is, not a trick, but a signal. Something flickering at the edge of perception, not there to fool us, but to remind us that some truths disappear the moment we try to touch them. Sometimes, in the dark quiet of the deep, something speaks, not in words, not in language, but in patterns, pulses, sounds that shouldn't be there. Unmanned submersibles have recorded whispers, clicks, rhythms that resemble coded signals. They arrive without source, echoing through pressure and silence, like voices searching for form. Most of these submersibles are built to listen. Hydrophones and acoustic sensors collect background noise, currents, thermal vents, the rumble of distant tectonics. But occasionally, they pick up something else. Soft sequences, 3 clicks, a tone, then silence, repeated days later, in a different part of the ocean. There was a case in the Mariana Trench where a deep-sea probe captured a 6-second pattern. Low hums, a rising tone, what sounded like distant knocking. The signal was irregular, not mechanical, not geological, and it came from a depth where no known vessel had been. The engineers reviewed the data again and again. It wasn't static. It wasn't a sonar bounce. It was something. Some dismissed it as acoustic artifacts, echoes trapped in underwater canyons, bouncing back in warped time. Others noted the frequency matched no known species, and no malfunction could explain the symmetry. A separate project near the Mid-Atlantic Ridge reported a different phenomenon. A whispering noise, recorded in multiple sessions by multiple devices, always between 2 a.m. and 3 a.m., always preceded by a long silence, always ending with a soft burst of static, like an exhale. No ships, no storms, no known cause. Some researchers suggest these are byproducts of seafloor movement or chemical interactions near hydrothermal vents. But others aren't so sure. These whispers don't behave like natural noise. They don't repeat like geological events. And they've never been fully reproduced. We don't know what they are. Maybe it's nothing. Maybe it's us, hearing patterns where there are none, assigning meaning to chaos. But in the quiet of the deep, where pressure distorts and silence becomes unbearable, a sound, even imagined, feels like a message. Whether it's from a creature or current, system or shadow, it reminds us of something we often forget. In a world this vast, listening might be the only way to know we're not alone. In the deepest parts of the ocean, light ceases to exist. There is no shimmer, no horizon, not even contrast, only pressure. Blackness so complete, It feels like being buried inside a thought. Yet even here, people see things. Deep-sea divers, submersible pilots, and researchers who've spent long hours beyond the reach of sunlight have reported visions. Not dreams, not memories, apparitions. Some describe figures drifting just beyond the glass. Others speak of dim pulses of light, pulsing not randomly, but in sync with their breath. The more they inhaled, the brighter the glow. The more they exhaled, the closer it seemed. This may sound poetic, but it has precedent. In sensory deprivation studies, hallucinations often mirror internal rhythms, breath, heartbeat, blink patterns, as the mind clings to the only stimulus it has left, the self. This is known as the Ganzfeld effect, a state where lack of sensory input causes the brain to fabricate its own images. At first, these are abstract, but given time, they take form, and those forms are often the same. Across oceans and cultures, people describe spiral corridors, glowing arches, cathedral domes suspended in blackness, watching eyes. One pilot reported seeing an immense stone ring rising above his submarine. Weeks later, a diver across the globe described nearly the same structure, down to the placement of its broken edge. Coincidence, perhaps? Or maybe something deeper. Psychologists like Carl Jung proposed the collective unconscious, a shared library of primal symbols etched into the human mind over millennia. When stripped of external stimulus, the brain may tap into these ancient forms, not individual memories, but shared inheritance. If the ocean invites these images up from within us, if darkness becomes a mirror, we must ask the next question. If such conditions can create reality in the mind, could they also interfere with our perception of the real world itself? Could we mistake what's imagined for what's actually there? Or worse, fail to perceive what's disappearing? Because not everything the ocean shows us is illusion. Not everything it takes is remembered. Some visions fade the moment we blink. Others vanish completely. Vessels, signals, entire crews gone without trace. Somewhere in that silence, something remains. The Bermuda Triangle is a name most people know, a stretch of sea between Miami, Puerto Rico, and Bermuda, where ships vanish, planes disappear, and compasses lose their bearing. It's not marked on official maps, but it exists in memory and in mystery. One of the most famous cases was Flight 19, a squadron of 5 Navy bombers that lost contact in 1945. They flew in formation, then drifted off course. Their final transmission was fragmented, confused. A rescue plane was sent. It vanished too. No wreckage was found. These aren't isolated events. According to maritime data, hundreds of ships go missing each year. Most vanish in storms, in silence. But a few leave no storm, no struggle, no trace. The MV Joyita, found adrift in the South Pacific, was fully intact, food uneaten, radios operational, but not a soul aboard. The SS Orang Medan drifted lifeless with its crew reportedly frozen in horror. The Cyclops, a Navy collier, vanished in 1918 with over 300 men aboard. No debris, no distress call, only absence. Most of these disappearances are attributed to logical forces, rogue waves, navigational error, methane eruptions from the seafloor, or electromagnetic interference. These explanations hold until they don't. Sometimes weather is calm, instruments are functional, coordinates are exact, and still, a vessel disappears. When that happens, a stranger question emerges. Maybe the ocean doesn't move things somewhere else. Maybe it simply lets them go. Maybe, for reasons we don't yet understand, reality down there can lose its grip. There is no splash, No floating wreckage, just quiet, complete, unreturning. In certain places, not even sonar echoes come back. It's as if the sea itself has closed, sealed around the moment, refusing to admit what it swallowed. What's left behind is not evidence, not explanation, only a blank coordinate, a question, a space on the map where something once was, and now is not. We like to believe that nothing truly disappears, that all things leave a trail. But in the ocean, some things leave nothing. Not silence, not memory, not even time, just gone. The deeper we go into the ocean, the more sound begins to deceive. At extreme depths, sound travels faster, slicing through dense water with startling clarity. Voices echo inside helmets. A dropped tool reverberates like thunder. And occasionally, something knocks. Not a creak, not a groan, a pattern. Throughout deep-sea exploration history, divers and submersible crews have reported rhythmic tapping sounds. Sharp, deliberate, often in threes, always followed by silence. In 2015, Japan's Shinkai 6500, a deep-sea research submersible operated by Jamstek, recorded a series of unidentified percussive sounds at a depth of 6,200 meters near the Izu-Bonin Trench. The taps were even-spaced, mid-frequency, and spatially localized to the aft of the hull. Post-dive review included spectrogram analysis, vibration dampening tests, and marine species frequency cross-referencing. No match was found. Hull strain, biological interference, and active sonar reflections were ruled out. Earlier accounts go back to the 1960s, when divers in the U.S. Navy's Sea Lab experiments described similar sounds inside test chambers, sometimes mirroring body movement or seeming to follow shifts in posture. Engineers attributed it to pressure fluctuations or thermal expansion in the metal, yet the patterns repeated across different dives and structures. One diver wrote in his log, "It sounded like someone was tapping on the outside, like they were trying to get in." Modern psychology offers another explanation. Apophenia, the tendency to perceive meaningful patterns in random data. Under stress and sensory deprivation, even the subtlest sounds can feel intentional, especially when there's nothing else to focus on. But not all sounds are internal. In 2022, an ROV descending into the Kermadec Trench, northeast of New Zealand, captured tapping from an unknown source. The pattern repeated over 40 seconds, 3 long, 2 short, then stopped. The trench showed no seismic activity. No vessels were nearby. The knocks were real, measured, archived. What causes them? Pressure? Metal fatigue? The sea making sense of itself? Or is it us, trying to turn randomness into rhythm, loneliness into contact, emptiness into story? Because sometimes, in the deep, a knock is only a knock. Sometimes, it's all that remains. Along the misted shores of northern Japan, they drift in, small wooden vessels, silent and weathered, their hulls splitting with salt. No names, no lights, no one aboard. Inside, the scenes vary. Some hold rusted tools, rain-filled shoes. Others preserve their last moments, meals uneaten, blankets folded, radios intact. In rare cases, skeletal remains. These are known as ghost ships, and while the name sounds folkloric, the phenomenon is real. Since 2011, over 100 such vessels have washed ashore, particularly in Hokkaido and the Western Sea of Japan. Most are traced to North Korea, likely used by fishermen pushed beyond their normal zones due to declining resources or political pressure. Often unequipped with GPS, radar, or emergency beacons, these boats drift when fuel runs out or storms roll in. their fate becomes the ocean's decision. But this isn't a modern story. Records from the Edo period tell of unmanned fishing skiffs arriving on Japanese beaches, rudderless, bleached by sun and time. Back then, they were seen as omens, touched with the divine. Today, we call them statistical anomalies. Still, not every story fits the data. Some boats arrive far off course, sometimes hundreds of kilometers from where prevailing currents and winds suggest they should have gone. Marine drift modeling, used by oceanographers to predict debris movement, can't always explain these anomalies. When no storm systems are logged and electronics remain operational, the mystery deepens. Then there's the feeling. The way they arrive, motionless on the horizon at dawn, gone by afternoon, reappearing days later, or never again. Why do these vessels haunt us? Perhaps because they reflect something deeper than misnavigation. They reveal our dependence on systems we assume will hold: GPS, engines, weather, reason. But the sea doesn't need permission to remove someone. It only needs time. We don't fear what we don't know. We fear the almost known, the note left unfinished, the story without a final page. Ghost ships are not just about who's missing, but about what remains. The salt-drenched blankets, the creak of wood under pressure, the faint scent of fish and diesel, left to fade beneath a sky that didn't witness anything, but swallowed everything. Perhaps that's what unsettles us most, that the sea can keep a secret, so gently, because sometimes it returns nothing. Sometimes it returns the shape of absence. Sometimes it leaves behind only silence. Other times, it leaves behind a light, one that doesn't belong to any vessel, beacon, or star. The ocean is dark, not just shadowed, but layered in pressure, silence, and distance from light. Which is why, when something glows down there, people remember. Naval reports dating back to the Cold War describe unexplained lights seen deep beneath the surface, often moving with purpose, sometimes tracking submarines for hours at a time. In one declassified Soviet log from 1984, a patrol sub in the Barents Sea reported being followed by a luminous object, pale blue, ovoid, silent. Sonar registered no contact. The object matched speed and depth changes, then vanished without trace. The crew filed a full report. The military dismissed it as a sonar ghost. These incidents aren't isolated. During U.S. naval exercises in the 1990s, multiple sonar technicians aboard the USS Memphis claimed to see structured lights through the periscope, moving in tandem with the sub, occasionally circling it. They called them bioluminescent entities at the time, but no known sea creature behaves that way at those speeds, or in those formations. Some scientists suggest that pressure changes might activate deep-sea bioluminescence, shrimp, jellies, or squid responding to mechanical disturbance. But these lights don't drift, they pursue. Some have been seen at depths too extreme for most life to emit light at all. Then there are the ROV encounters, remotely operated vehicles catching brief footage of blue or green flickers in pitch darkness. The patterns suggest intent, but the sources remain unidentified. One of the most confounding sightings came in 2013. A research submersible descending into the Mariana Trench caught a single steady light about 50 meters away, unmoving. The sub adjusted course. The light maintained distance. Cameras focused, and it blinked out. There was nothing on sonar. The event lasted 6 minutes. The recording is archived, still unexplained. Are these anomalies natural, unknown species, electromagnetic echoes of our own devices? Or are we being watched, in a place where we do not belong. The deep ocean resists exploration. It crushes our machines, confuses our instruments, yet sometimes it sees us. That's the strange tension of these lights. They don't try to make contact. They don't flee. They simply appear, observe, and vanish. In extreme environments, our minds seek connection, signals, patterns, intention. A light in the dark becomes more than a light. It becomes a gaze. Perhaps what unsettles us most is the possibility that we were never alone. When we try to look back, when we aim our sonar to ask the deep what was there, we find only silence, only echo. Sometimes, not even that. Sonar is one of the few tools that allows us to explore the deep without light. At its simplest, it sends out pulses of sound that bounce off objects, revealing distance and direction. With more advanced systems, like side-scan or multi-beam sonar, we can begin to infer size, shape, even material density. But even these tools are imperfect. They rely on interpretation, on echoes, on guesswork in the dark. Sometimes, something answers, then disappears. Over the years, researchers and naval crews have reported transient sonar contacts, distinct echoes of large objects that appear once and never return. Some are dismissed as sensor errors or reflections. Others resist explanation. In 2013, during a deep ocean survey in the Gulf of Alaska, scientists aboard the RV Sikuliak recorded a dense sonar return roughly 70 meters wide. It hovered at 600 meters depth for nearly 3 minutes, then dropped away rapidly out of range. A second sweep found nothing. No sediment cloud, no biological trail, nothing at all. A similar event was documented by the Soviet Navy in 1986 during a patrol in the Greenland Sea. Logs describe an unregistered submerged object pacing their sub for several kilometers, detected clearly on sonar, yet invisible to periscope and infrared scans. When sonar swept again, the signal was gone. Engineers reviewing these incidents often cite thermoclines, sharp changes in water temperature that bend sonar beams, creating the illusion of solid targets. Others point to deep scattering layers, massive swarms of fish and plankton that reflect sonar in complex ways. These explanations don't always fit. Thermoclines don't hover and vanish. Scattering layers don't accelerate or follow. Most of the time, these anomalies are logged, noted, and left unexplained. What makes them unsettling isn't just their presence, it's the lack of closure. Sonar is supposed to provide certainty, a way to map the dark. Sometimes, the ocean only offers a glimpse, then silence. There's a quiet link here to the underwater lights we saw before. Those flickers without origin, tracking us in silence, only to disappear as soon as we take notice. With sonar, there is no glow, no visible form, just the sense that something was there, and then chose not to be. Are these false signals? Unknown marine animals? Misreadings of a medium we barely understand? Or are they something rarer? Encounters not with forms, but with limits? The deeper we reach, the more we confront the edge of our perception, the moment where presence turns to uncertainty, and the echo fades before it can be named. The ocean gives us many answers. It also humbles us by showing how little we're equipped to ask the right questions. Sometimes, in the space between pings, we hear something else. Not a contact, not a shadow, but a sound. Not mechanical, not random, just strange. During the Cold War, silence was survival. Submarines patrolled the depths like phantoms, built to vanish, to listen, and to wait. Sometimes, what they heard wasn't in any manual. Between the 1960s and 1980s, both American and Soviet crews began documenting a series of unidentified underwater audio phenomena, sounds that didn't match any known vessel, earthquake, or marine animal. One of the most enduring was the kvaka, or quacker, reported by Soviet subs operating in the Barents and Norwegian seas. Described as a rhythmic clicking or croaking, the sound would sometimes track a submarine, mirroring depth changes and heading. When the crew attempted to approach or record it more closely, it would vanish. Western reports told a similar story. In 1977, the USS Batfish, a Sturgeon-class submarine, recorded a low-frequency mechanical hum in the Pacific. The sound lasted nearly 12 minutes, pulsing steadily, like a slow machine, before stopping mid-pattern. Analysts ruled out propeller cavitation, volcanic activity, and known marine species. The recording was archived and never explained. Hydrophones across the SOSUS surveillance network picked up other anomalies: broadband roars, tightly spaced harmonic tones, or isolated pulses that repeated at regular intervals. Some were so regular, they sounded manufactured. Others resembled nothing in human or animal records. Scientists and engineers offered theories. Some pointed to deep scattering layers, clouds of marine organisms that reflect sound unpredictably. Others blamed standing waves created by pressure and temperature gradients. A few speculated on the vocalizations of undiscovered deep-sea species. Some of these sounds didn't behave like biology. They shifted frequency, changed direction, followed. Decades later, researchers still revisit Cold War audio archives, digitizing old reels, feeding them into machine learning models, searching for overlooked signatures. Some mysteries have been solved. Most haven't. There's something different about these. Unlike sonar returns or brief flickers of light, these events were heard directly, repeatedly, logged by trained crews across oceans and ideologies, each reporting the same: something mechanical, intentional, unplaced. We often assume that what we hear was real. That sound means presence. What if some presences only exist in passing? They echo once and never return. Somewhere in the dark, something spoke. We're still trying to understand what it said, because we trust that sound means something was there. Now we move to stranger ground, where even presence itself can vanish mid-sentence. Submarines are designed to vanish, to slip beneath the surface and become an absence, intentional, traceable. Vanishing with purpose is different than blinking out mid-sentence. In 1968, the USS Scorpion, a nuclear sub returning to Norfolk, transmitted one last routine message. Hours later, it failed to arrive. No emergency ping, no sonar anomaly. Just silence. Debris was eventually discovered near the Azores, but no single cause was confirmed. A torpedo malfunction was suggested, but nothing proven. That same year, the Soviet K-129 disappeared beneath the Pacific. No call, no warning. Theories range from internal failure to an aborted missile launch, all inconclusive. These weren't wartime incidents. There was no combat, no storm, no seismic event. Yet they were just 2 of 4 submarines lost in 1968, a year still regarded as the most quietly catastrophic in undersea history. Submarine communication is complex. Very low-frequency radio waves can penetrate shallow water, but anything deeper requires surfacing, buoys, or sonar bursts. When contact is lost, the failure usually shows itself in stress signals, mechanical logs, technical alarms. Sometimes there's no error, no fade, only discontinuity. In 1999, the French submersible Nautil lost signal during a descent into the Puerto Rico Trench. For 11 minutes, the feed went black. Then, returned. No time loss, no damage. The crew remembered nothing unusual. The data logs were seamless, except for the part where they weren't. Some call these signal anomalies, others blinks. But it's what they imply that disturbs us. That contact is not constant. That presence is not guaranteed. To lose connection is one thing. To lose the sense that something is still there, that's harder. It echoes a deeper fear, that something trusted, something tangible, can vanish without warning. Not through violence, but through absence. Not lost in a crash, just gone. We don't always notice until the silence is too perfect, until we realize we were still speaking to something that had already disappeared. We expect the deep to be dark, and yet it glows, not from sunlight, but from life itself. Silent, shimmering pulses drifting through pressure and cold. Bioluminescence is one of the deep ocean's dominant languages. Nearly 90% of species below 1,000 meters produce their own light. Some use it to hunt, some to hide, some to speak without sound. But sometimes, the lights don't behave like animals. In 2003, the Shinkai 6500, a Japanese deep submersible, recorded a first-hand sighting at 1,200 meters. 3 distinct lights, glowing blue-white, trailing the vessel in a perfect line. No body, no propulsion, just light, holding pace. When the crew turned to observe them directly, the lights floated backward, then disappeared. Not dimmed, gone. The onboard cameras showed nothing, but every pilot reported the same pattern: synchronized spacing, intelligent pacing, coordinated retreat. In 2016, off the Galapagos, an autonomous submersible captured 2 lights circling its chassis in synchronized spirals. 12 seconds into the event, the footage was lost to static. The sub reported no malfunction, only the interruption. Scientists offer careful possibilities: free-floating photophores, dislodged luminous tissue, reflections of the craft's own lights in drifting particulates. Valid ideas. But there's a problem. Most natural bioluminescence is chaotic, flickering, tumbling, diffused by the current. These moved with intention. They followed. They mirrored. They observed. Some aren't humanoid in form. Those are the words the crew use. Not for the light itself, but for how it felt. Seen. Not just recorded. Witnessed. In a world where light bends, sound fragments, and perception slips, what does it mean to be watched by something you cannot describe? Not tagged, not classified, just present. We catalog deep-sea light by frequency, pattern, decay rate. Some phenomena resist taxonomy, not because we lack data, but because something in us hesitates to name what might be looking back. We log these sightings as anomalies, label them with gentle distance: unexplained, responsive, observer class. Sometimes, even in science, the record begins not with data, but with the feeling of eyes in the dark. In 2009, Google launched a new tool, Google Ocean, allowing users to explore the seafloor using satellite-acquired bathymetric data for the first time. Almost immediately, people noticed something strange. Off the coast of the Canary Islands, beneath miles of ocean, lay a massive grid-like formation, rows of straight lines intersecting at sharp angles, stretching across hundreds of miles. The layout resembled a city blueprint, not the random contours of tectonics or seafloor erosion. Rectangular zones, parallel corridors, consistent spacing. Some of the segments measured over 100 miles long and nearly a mile wide. Speculation spread fast. Was this a remnant of a lost civilization? Atlantis. Evidence of intelligent life now buried beneath the waves. But oceanographers from the British Oceanographic Data Centre and NOAA responded quickly. They explained the pattern as a technical artifact, a byproduct of how sonar mapping ships collect and assemble seafloor data. Unlike satellites that capture a single image, seafloor scans are gathered in strips, long, narrow passes made by ships bouncing sound waves off the bottom. When those strips are stitched together, overlapping zones can sometimes produce artificial patterns, including straight lines or grid-like seams. From a scientific perspective, this was the most likely answer. No excavation, no direct evidence, just a stitching artifact, like a printing error on a map. Still, some noticed that not all sonar-stitched maps produce such geometric perfection. Some patterns persisted even in later updates, long after initial scans were replaced with newer data. The most likely explanation remains data assembly, but the impression it leaves is harder to dismiss, because it looks familiar. We've seen grids like this in satellite imagery of abandoned cities. We've uncovered similar layouts in jungle-covered ruins, revealed by modern LiDAR. When we see structure, even imagined, our minds assign intention. The ocean, after all, hides not just life, but history. Whether the Atlantic grid is a glitch or a ghost, it reminds us of something deeper. That pattern suggests purpose. That symmetry lingers, even when the builders do not. In a place as vast and unmapped as the seafloor, sometimes, it is the shapes that shouldn't be there that whisper the loudest. In 2001, a private expedition scanning the seafloor off the western coast of Cuba reported something unusual. Using side-scan sonar near the Yucatan Channel, the team claimed to detect massive, angular shapes deep beneath the ocean. Geometric, symmetrical, almost architectural. The lead researcher, Paulina Zalitsky, suggested that the sonar data revealed a submerged pyramid-like formation, possibly with a glassy or polished appearance. Reflective, smooth, too consistent to ignore. The formation sat over 2,000 meters below the surface, far beyond the reach of sunlight, and deeper than most submersibles dared to go. Early media coverage spread rapidly, and in the early days of internet forums and digital conspiracy culture, speculation bloomed. Atlantis, pre-Ice Age civilizations, lost temples of light. But no peer-reviewed studies followed. No university surveys. No scientific consensus. Just a handful of interviews. A few still images. And then, silence. The research team, a private company, not an academic institution, never published detailed methodologies or follow-up data. The scientific community remained cautious and skeptical. Sonar reflections can be deceiving. Fault lines, rock shelves, volcanic uplift. In the deep ocean, natural features often look intentional when scanned in narrow bands. What appears to be a wall might be sediment sliced by light and pressure. And yet, the patterns recorded were compelling. Cubic voids, parallel edges, order, in a place we associate with drift and entropy. The most likely explanation is geological misinterpretation, a feature that mimicked form without function. Still, the image remains, a silhouette of symmetry in a void without names. We've always been drawn to order, from constellations in chaos to cities beneath jungle canopies. We see meaning in alignment and stories in stone. Even when there's no builder, only erosion and coincidence. The ocean reminds us not all mysteries are real. Some are projections of what we wish to find. But even projections have value, because they show us what we're hoping for, whether artifact or artifacting. This claimed structure reminds us it isn't just life the ocean conceals, but the stories we're still hoping to remember. In 1986, a diver exploring the waters near Yonaguni Island, Japan, came across something unexpected. Not coral, not rubble, something massive and angular. Just 20 to 30 meters below the surface lay a vast formation of ledges, steps, and terraces, cut with such clean lines, it seemed intentional. Flat platforms stacked like a ziggurat, sharp corners, symmetrical angles, all embedded in the seafloor and extending over 75 meters in length. To some, it looked like the remains of a sunken city, a ceremonial site, perhaps, carved and then swallowed by rising seas. To others, it was a trick of erosion, a natural formation, made strange only by our eyes. One voice has stood out: Japanese marine geologist Masaki Kimura. After years of surveying the site, he proposed that it might be man-made, the work of an ancient people, long before the rise of known civilizations in the region. He suggested that if it were constructed, it would date to over 10,000 years ago, when sea levels were lower and Yonaguni's coastal plains lay exposed. He's even claimed to find what appear to be steps, walls, roads, possibly even inscriptions. But Kimura's interpretations are controversial and largely isolated. The vast majority of marine geologists disagree. They point out that Yonaguni's layered sandstone and mudstone fracture naturally along bedding planes, which can form clean, step-like features when shaken by earthquakes and eroded by currents. So far, no tools, artifacts, or signs of construction have ever been recovered from the site. No pottery, no post holes, no evidence of human habitation. Which raises the question, are we seeing a monument or just a pattern? Because patterns are powerful. A platform can suggest purpose, a staircase, direction, a right angle, design. We're drawn to these things, especially in places where meaning feels absent. A vast ocean, a silent seafloor, and suddenly, geometry. Even if the Yonaguni monument is natural, a result of time, pressure, and stone, it still tells us something important. That we're always scanning for intention, looking for the mark of others, the evidence that we're not the first to be here, not the first to build, or to lose what we built. Whether carved or broken, deliberate or coincidental, the monument remains. Not proof of anything, but a question carved in stone. One we're still swimming around, decades later. In 2011, a Swedish dive team scanning the floor of the Baltic Sea found something strange. A large, circular shape, nearly 200 feet across, resting over 90 meters beneath the surface. The sonar image was low resolution, but distinctive. A raised disk, a central dome, symmetrical ridges. Some said it looked like a submerged spaceship. Others called it a ruin. But geologists weren't convinced. The group behind the discovery, OceanX, a commercial exploration outfit, released the image online, framing it as a potential lost artifact. They described unexplained malfunctions during dives, electrical systems failing, cameras flickering, strange compasses. These reports were never verified. No peer-reviewed study ever confirmed such disruptions, and the shape itself, never directly observed, only scanned. Most experts proposed a simpler explanation. The object is almost certainly a glacial deposit, a fragment of the Earth's icy past. During the last ice age, Immense sheets of ice once crawled across the region. As they receded, they dragged stone and sediment across the seafloor, sculpting ridges, depositing boulders, grinding lines into the bedrock. The Baltic Sea is filled with such erratics. This one just happened to look unusual. The formation's symmetry, its so-called corridors and ramp, were likely sonar illusions, stretched or flattened by the angle of scanning. And while Ocean X claimed to find unusual materials, metal fragments, even glass-like elements, no lab or academic journal has confirmed their presence. The samples remain ambiguous. No artifacts, no tools, no structures, only shapes. But the anomaly caught fire. Quickly. It made headlines, inspired documentaries, spawned theories. For a few years, it echoed alongside other seabed discoveries, like the Bimini Road or the Cuban Pyramid, natural formations mistaken for design. It tapped into something older than sonar, the belief that human hands must have shaped what appears deliberate. Maybe that's the point. We sharpen blurry lines. We build architecture in randomness. The mind seeks meaning, even when none is there. Today, the Baltic Sea Anomaly rests untouched, largely forgotten by science, but not by imagination. Because even if it's just ice-scoured rock, it still looks back at us from the dark. A circle where none should be. A silence shaped like intention. In the deep ocean, we navigate by sound. Where light fades and darkness swallows form, we rely on echoes to see. Sonar sends a pulse and waits for something to bounce back, a shape, a distance, a delay in time that becomes a picture. But sometimes, what returns is more story than signal. Over decades of exploration, sonar technicians have documented strange readings, upright forms, towering blocks, objects with clean edges, symmetrical and smooth, rising suddenly from the flat sea floor. They appear in side-scan imagery, sometimes once, sometimes again, days later. But when cameras descend, nothing. One example emerged during a 2005 mapping survey off the coast of British Columbia. Multiple sonar passes recorded a structure over 10 meters tall with a consistent rectangular profile. When divers reached the coordinates, they found only rippled sediment and no signs of collapse or displacement. What happened? These anomalies are not fiction. They're called multi-path artifacts, illusions created by sound traveling through complex ocean layers. Temperature gradients, salinity differences, and shifting current lines can all bend sonar beams, redirecting them along longer paths. The returning echo may come from below the actual object, or from something nearby, refracted through invisible boundaries. Certain seafloor compositions, like layered clay over bedrock or gas-charged sediments, can further distort or scatter sonar pulses. Low-frequency sonar is more likely to penetrate sediment and return ghostly traces from buried layers. High-frequency scans reveal sharper images, but cover less distance and are more prone to misreadings from small debris. Even advanced systems aren't immune. Multi-beam sonar, side-scan arrays, and interferometric mapping tools still encounter false positives, shapes that emerge in one pass, then vanish on the next. As sonar resolution improves, we're catching more of these tricks in real time. The deeper we scan, the stranger the signals become. So we ask, what does it mean to witness something only once? To chart a structure in sound, but never in light? In the language of sonar, everything is interpretation. A pause becomes a pillar, a ripple becomes a ridge, and sometimes a fleeting echo becomes a monument that was never there at all. The ocean does not lie. It speaks in half-truths, shaped by physics, scattered by pressure, and bent through a medium we barely understand. We listen. We interpret. We redraw the map again. Sometimes, the map redraws us. In the shallow waters off Bimini Island, in the Bahamas, lies a road that leads nowhere. Discovered in 1968 by zoologist J. Manson Valentine, it stretches across the seafloor in a straight, unnerving line, a sequence of flat, angular stones, some over 4 meters across, resting edge to edge like tiles from a long-forgotten causeway. No tools, no markings, no explanation. Divers found more stones beneath the first layer, deeper, offset, seemingly stacked. Some even appeared to rest on smaller rocks like supports. The structure felt deliberate, but no structure remains. To many, it whispered of Atlantis, of sunken civilizations and roads swallowed by rising seas. And yet, the science is surprisingly quiet. These stones are beach rock, a sedimentary limestone that forms when sand and shell fuse near shorelines. As it hardens, it fractures cleanly along bedding planes, producing rectangular blocks that mimic masonry. The linear layout? Natural. These formations tend to break in rows, parallel to the ancient coastlines where they formed. Carbon dating of embedded shells suggests these rocks are about 2,800 years old. But marine incrustations above them indicate they've been underwater for at least 2,000. The last time this area stood dry, during the last ice age, was over 10,000 years ago. If the stones were carved, they would have had to be shaped before recorded history. Still, something about them resists dismissal. We see lines and imagine blueprints. We see order and feel origin. Perhaps it's because roads speak to us. They imply presence, passage, purpose. Even when formed by chance, patterns linger in the mind. Maybe the ocean carved these stones by accident, but we follow them anyway. Not because they lead somewhere, but because they suggest someone once did. Some parts of the ocean resist observation, not because they're deep, not because they're hidden, but because something in them bends the signal back. Sonar isn't light, it's sound. It travels in waves, bouncing off the seafloor, returning to the surface as a map of echoes. But under certain conditions, those echoes vanish. Not into blackness, but into uncertainty. It's called an acoustic shadow zone, a phenomenon where sound waves curve around an area, leaving it momentarily untouched by the scan. This can happen when warm and cold layers of water, along with salinity and pressure, create refractive boundaries. To sonar, these zones are invisible, as if the sea has pressed mute on a particular space. Sometimes, even loud signals strong enough to bounce off submarines or mountains, pass over these zones and return with silence. Nothing. No reflection. No scatter. No shape. Just absence. These anomalies aren't supernatural. They're physics. But that doesn't make them any less strange. In 1963, during Cold War naval testing in the North Atlantic, submarines disappeared from sonar range for hours. Not because they moved, but because sound bent around them. The U.S. Navy would later use this to their advantage, hiding vessels inside these folds of silence. There are other factors too. Sediment composition, seafloor geometry, and thermoclines, layers of sudden temperature change, can scatter or absorb sonar in unpredictable ways. Even biological activity, like dense schools of fish or plankton blooms, can disrupt acoustic returns. Radar, too, isn't immune. Though it operates in air, radar can be disrupted by ducting layers in the atmosphere, especially over calm seas, causing strange blips to vanish, or appear where nothing exists. In some regions, like the Indian Ocean, the North Pacific, and parts of the Southern Ocean, researchers have documented dropout zones where instruments repeatedly underperform without clear mechanical cause. Are these zones truly unknowable? Number. They are reminders that measurement is not the same as understanding, that even the most advanced instruments can be humbled by a layer of salt, a tilt in temperature, a boundary between stillness and motion. The ocean isn't always hiding its secrets. Sometimes it's simply asking us to listen differently. In 2020, a sonar pass off the coast of Western Australia revealed something no one could explain. A diagonal formation, descending from the sea floor, clean, geometric, like a staircase carved into the earth itself. Each step was smooth, evenly spaced, until the last. It ended in a jagged break, as if construction had stopped mid-thought. The crew ran a second scan, same result. A stairway, vanishing into a trench that returned no echo, no debris, no slope, no visible base, just absence. Sonar can lie, of course. Temperature layers, sediment density, even current shifts can bend a signal's return. But this was different. It wasn't a smear or blur. It was precise, repeated, real, or something shaped like real. No one returned to investigate. There were no dives, no samples, just a still frame in the archive and a single technician's note. It felt like a place left unfinished. The ocean has offered illusions before. Natural formations that look like roads, temples, pyramids, beach rock, jointing fractures, erosion carved by time. Maybe this was no different. A trick of signal, sculpted by silence. But then, beneath that final stare, a soft blue glow. Not bright, not moving, just barely there, flickering behind the static. It faded by the next scan. Some called it a sensor glitch. Others said it never existed at all. But if you trace each step down, past the break, past the silence underneath it, you may feel something quiet. Not fear, not awe, just stillness. The kind that settles when a question has no answer. Beneath the biology, beneath the structures and scans and stories, there may be places that do not care to be understood. Spaces that ask nothing and give nothing back. A staircase not meant for climbing, only for imagining. And perhaps that was all it was ever built for. We've reached the edge of the map, where signals fade and questions remain. Thank you for drifting with us in the deep.